Hello everybody and welcome to the MLittleProgramming tutorial. Please drop a like on the video as it really helps the channel, and subscribe if you haven't already. Let's get into it. In this video we're going to be looking at if statements in Python, how to use if statements, how if statements work more generally, and how if statements can create different flows through your code. This is the first time in this series so far that we're going to be taking a look at the logical section of the Python programming language. What is logic in Python? Logic is a programming paradigm in which program statements express facts and rules about problems within a system of formal logic. They allow for statements about what the program should accomplish with no explicit step-by-step instructions on how to do so. So if we take that grocery example from the last video, we have a list of groceries that we need to buy from the shop. A simple run-through of a program could be a step-by-step sequence of events to go to and buy those items from the shop. For example, leave house, turn right, start walking. When you reach the shop, look for your first item, apples. However, as you can probably see at some point, like with your everyday life, when these scenarios play out, you'll need to make a decision. What happens if, when you get to the store, there are no apples? Well, in the case of this program, it doesn't know what to do, so it will just stop. However, if you went to the store and there were no apples, you may be upset because now you just can't keep that doctor away. This is obviously a different flow of events that would have happened if there had been apples at the store. If statements allow us to build that logic into our programs and allow the program to make decisions and not just rely on step-by-step instructions. So how does an if statement work in Python? An if statement has a Boolean condition. Booleans have one of two values, true or false. If that Boolean value is true, then we enter a code block that we will define. If not, then we will continue with the original flow of the code. We can think of this like a flowchart. We have a flow of code, we reach a decision or a condition. If that condition is true, then we move to a separate code block. If not, then we continue moving on with the same path that we were on before that condition was there. Let's hop into PyCharm now to go through the Python if statement syntax. So to tell Python that you're going to want to create an if statement, you need to use the if keyword. You'll notice that this if keyword has changed colour. This is PyCharm's way of indicating to us that this is a reserved word in Python, meaning that it has some functionality that we can take advantage of. Next to the if keyword after a space, we can place our condition. As I mentioned earlier, this is a Boolean value. If this value evaluates to true, then we'll execute a block of code that we're just about to define. So for this first example, we're going to keep it simple and define the condition as the Boolean value true. Notice that Python Boolean values have the first letter capitalized. Again, the word true's color has been changed by PyCharm as this is a reserved word. This means that the condition will evaluate to true and the if statement code block that we are just about to define will be executed. If statements work in an if true then syntax. To tell Python we've finished the condition evaluation step, and we use a colon to represent the then step. So far we've told Python that if true is true, then execute something. Now we need to define what we are executing. This brings us to one of the most important syntax features of Python, indentation. How your code is indented will have a huge impact on how Python reads your code. You will notice that we only need a colon to open our if statement. We don't use any character or symbol to close that if statement. Python works out where the code block of your if statement ends by each line's indentation. Python works on a 4-space indentation rule. PyCharm helps us follow this rule by indenting automatically for us when we write if statements. But let's go over what this rule is and why it is important. The rule essentially comes from it being the consensus within the Python community. Now you may be thinking, what about tabs? Well, we could do a whole video on tabs versus spaces debate, but I'll go over it briefly now. Essentially, depending on the editor that you're using, a tab can be defined as 2 spaces, 4 spaces, 8 spaces, or any number of spaces. So this means that if you're using tabs and you're working with both your own code and with other people's, say you're working at a company and you're working with code base with other people, or you're just working on your own personal projects, but you need a little bit of help, so you take the classic developer approach and look for an answer to your problem on Stack Overflow and copy the code from there. You can run into problems because of the indentation level could be different to yours. Python could read your code in a way that you did not intend. For example, if your editor decided that a tab is equivalent to a width of 8 spaces, then your code will be an indentation level 2 when you intended it to be on indentation level 1. But let's switch back to if statements. We want to tell Python what to do if that condition we set is true. So we're going to indent by 4 spaces, 1, 2, 3, 4. For this example, we're just going to do the most basic line of code. We're going to print the string in if. Let's run this. Now, as you can see, the statement in if has been printed. Within these if statement code blocks, we can have as many statements as we like. So to prove this, we'll add the line print multiple lines. When we run that, we'll see that both lines have been printed as the condition is evaluated true to true. When we run that, we'll see both lines have been printed as the condition has evaluated to true, and it will just run all of the code within this code block until the indentation changes. Let's remove that second line to make the code clearer and think more about how if statements affect the flow of our code. So Python reads your code line by line. So with the code we have so far, it will read if true, then, and because that code condition is satisfied, it will move to the next line, which is our print statement. Now, let's add another line, but on indentation level 0. So the code that will be executed should our condition be true is on indentation level 1. But let's see what happens when we have both the if statement and then the code following that if statement. Let's print the string outside if statement. Now, as you can see, that outputs both the code inside the if statement and then Python will continue executing the flow of the code below it, printing outside if statement. Now let's change the condition to a value that evaluates to false. So we'll do the most basic condition that will evaluate to false. That is just replacing the true condition we had earlier with the false Boolean value. Let's keep the rest of the code the same, run it, and see what happens. As you can see, this outputs just outside if and not the in if string. This is because we failed the if condition, so we didn't go into the if block. Even though that was the case, we still continue with the flow of code as if the if statement wasn't there, and just continue and print outside if. In Python, there are also other variations of if statements, such as being able to include an else clause. An else clause is a catch-all for when our condition doesn't evaluate to true. When our condition doesn't evaluate to true, Python will jump to the else clause and begin executing the code we define within the else block. To create an else clause, we go to the indentation level that the if clause is on, and then write the word else, followed by a colon. We press enter and PyCharm follows the indentation rule for us. Then we can write a statement within the else block, so we're just going to put the string in else. Let's run that, and what we see is that because the condition evaluates to false, we don't go into the if block, but we go into the else block, and we print in else. Then Python follows the code as if this if block wasn't there, and looks at the next line as before, and prints outside if. Now let's make these conditions a bit more complex. A Boolean condition doesn't just have to be these Boolean values we've been using so far. They can essentially be anything Python can evaluate. So let's define two variables before the if statement. If you would like a more detailed look at variables in Python, there'll be a link in the top right of the screen right now, and I'll put a link down in the description. The first one we're going to call A, and we're going to assign it to the integer 1. The second we're going to call B, and assign it to the integer 2. We're going to replace the condition false with an integer comparison between A and B. So we'll say A equals B. A double equal sign in Python compares the two values. Python would evaluate the statement and produce a Boolean value for us. 1 is obviously not equal to 2, so Python will evaluate this to false. When we run this, we'll see the result of this statement is that Python will execute the else statement by printing in else. In fact, any mathematical operator in Python can be used to produce a Boolean value, and therefore we can use any mathematical operation in an if statement. Let's do one that evaluates to true, so we'll use less than. In this case, A is less than B, so the statement A is less than B will produce a true result, and we'd expect the if section of the if statement code to be run. Let's try and run that, and as you can see, the Python program outputs in if. So far, we've been comparing the value of two variables. We don't have to do this, and we can just compare two raw values. Let's look at comparing two strings. We can use the double equal sign in string value comparison. Let's compare the strings MLittleProgramming and programming, and see if their values are equal. Obviously the values of these strings are not equal, and Python just outputs in else. This also allows us to do calculations within the condition statement. So for example, we have these two strings, MLittleProgramming and programming. We can calculate the length of the string in Python by passing the string into the length function. To call the length function, type len, then open parentheses, and place your string inside the parentheses. The length function returns an integer value. We can use the integer comparison we were using earlier to create a Boolean value for our condition. So we'll use the greater than operator to ask, is the length of the string MLittleProgramming greater than the length of the string programming? When we run that, we'll see that obviously the length of the string MLittleProgramming is not greater than the length of the string programming, and therefore results in the string in else being printed. There is a final variation of the if statement that Python allows us to do. That is else if. So the code we define under the if block is run if the condition is true, and so far if that condition is not true, then we enter the catch-all else statement. However, what if we want to write a program where we want to catch multiple events happening? Let's go back to our variables. We don't need B anymore, so we can delete that. Let's set A to 3. As a basic example, let's say we didn't know what the value of A was, and we wanted to print out the value of a using an if statement. What you could do is something like this. For each of the possible options, have an if statement. So if a equals 1, print a equals 1. If a equals 2, print a equals 2. If a equals 3, print a equals 3. And if a doesn't equal any of these options, make the last if statement an if-else statement to catch all of the other cases. However, with else if, we can do all of this in one combined if statement. We can say if a equals 1, print a equals 1. Else if a equals 2, print a equals 2. Else if a equals 3, print a equals 3. Then we can do a catch-all for the rest of the cases of this whole statement. And we can see this in action by running this program. Thank you for watching this video. I hope you got a lot of value from it. If you would like more Python programming tutorials, there is a link in the top right now, and a link in the description down below to a playlist of Python programming tutorials. With that said, if you enjoyed the video, please drop a like as it really helps the channel, and subscribe if you haven't already. Also, if you've got any questions, drop a comment down below and I'll get back to you.